Module 6, Lesson 7 is the last lesson of the class. Yay! Okay, and we're going to talk about similar figures. Two triangles are similar if the corresponding sides are in proportion and corresponding angles have the same measure. So here's the deal on it. AB corresponds to DE. BC corresponds to EF. And AC corresponds to DF. Okay, so you can see the corresponding. They're not necessarily equal, but they're in the same ratio. It might be 2 to 1, 1.5 to 3, whatever, which is actually 1 to 2. Anyway, but the angles are equal. Angle D and A are going to be the same. B and E will be the same, and F and C will be equal. So number 1 says find the ratio of the corresponding sides of the given similar triangles. So small to large. So 5 corresponds to 10, and 4 corresponds to 8. So the ratio is really 1/2, 1 to 2. Could I do large to small? Absolutely, and say 2 to 1? Absolutely. So they don't give you a way to state it. You can do it either way. Now let's use this information to get some solutions to sides we don't know for triangles. So we're given that these triangles are similar, and I want to find this value. So I look at 39, and that corresponds to 13. So here we go. So 39, big triangle, is to small triangle, as N, which is the big triangle, is to the small triangle of 5. These are corresponding sides. Good? So I am going to cross multiply and divide. So here we go. 39 times 5 is equal to 195, and that equals 13n. So then I'm going to divide by 13. I think I'm going to get, 15. So n is equal to 15. And the nice thing is I don't have to put units because they didn't tell me what units it were. Okay, a flagpole casts a shadow. Here's the flagpole. Casts a shadow of 31.5 feet. Nearby, a 9-foot tree casts a shadow of 7 feet. I'm going to label these in feet here. What's the height of the flagpole? So these are similar triangles. So I'm going to do large 31.5 corresponds to 7, as x corresponds to 9. Large to small, large to small. They have to match up, just like we did with proportions. So 31.5 times 9 will give me 283.5 is equal to 7x, and then we're going to divide by 7. And so x is equal to 40.5 feet. And we're expecting it to be a little larger than the shadow because the tree shadow is a little bit larger, smaller than the tree. Here's the shadow. Shadows are always on the ground. They're never diagonal or slanted. Next, here we go. A firefighter needs to estimate the height of a burning building. Flame, 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 flame. She estimates the length of her shadow. This is the firefighter person. The length of her shadow to be 8.5 feet. And the length of the building's shadow to be 63 feet. Find the height of the building if she is 5 2/3 feet. Now what she's doing, I'm sure she did this after the fire was out. Now it said it's burning. I don't know. Anyway, again, similar triangles. We'll do 63 to 8 1/2, shadow to shadow. As x is to 5 2/3. So here we go. Let's multiply. I never miss an opportunity to work with fractions. It's like my favorite thing. So it's 8 1/2 x, 63 times 5 2/3. Well, let's rewrite 5 2/3 as an improper fraction, which is 17 over 3. And 8 1/2 written as 17 over 2. Oh, what a coinky dink this is going to be. 3 goes into 63. 3 goes into 3 once. 3 goes into 63 21 times. So now I have 17 over 2. X is equal to 21 times 17. And you're like, why aren't you multiplying it? You'll see. And what I need to do is get rid of that fraction, so I'm going to multiply both sides by the reciprocal of 2/17. Look at this. These will divide out and get 1. And look at how cute the little 17s cancel, so I don't have to worry. So this will be 42 feet. So the building is exactly 42 feet. I didn't do any approximation at all, although she did some approximation in her estimation. We're done. Okay? You know the drill. Good luck. You're almost done with the course. Good job.